Welcome to Quantum Education. In this episode, we're tackling one of the most frustrating problems in math education. Why do smart kids make so many careless calculation mistakes? The answer goes far deeper than simply an attitude issue. Many complex errors stem from a simple concept: series-connected probability. Think of any vertical calculation, multi-digit addition, subtraction, or multiplication. These aren't single steps. They're a series of basic facts, primarily addition and subtraction within 20. If a student is 95% accurate on each basic step, a problem requiring just 3 steps, like 549 plus 764, drops the final accuracy to about 86%. For a complex 24-step problem, that 95% accuracy rate makes the chance of getting it right less than 30%. The math is brutal. To guarantee a 95% chance of solving that complex problem, the student must achieve 99.8% accuracy on the basic facts. That's only one mistake every 500 questions. Good enough simply isn't good enough. So, how do we get to 99.8%? It requires training the brain in 2 ways: building parallel neural pathways and expanding working memory. First, parallel pathways. If one path to the answer fails, you need a backup. For a basic calculation like 8 plus 5, a student should know multiple methods, making a 10, 8 plus 2 plus 3, and thinking of it as 8 plus 3 plus 2, 10 plus 5 minus 2. When 2 methods, each 95% accurate, are used to cross-verify, the final accuracy jumps to 99.75%. The goal of practice isn't just to memorize, it's to develop these multiple problem-solving paths, which is the definition of number sense. Second, working memory. This is your brain's temporary notepad. Complex calculations quickly overloaded. If a student can barely hold the numbers and the carryovers in their head, stability plummets. You can train this mental muscle. Encourage brain-powered activities like strategy games, puzzles, and even simple memory exercises. The final piece is executive function. This is the ability to strictly follow a procedure and control your behavior to use tools correctly. Since our memory is limited, we use vertical calculation, paper and pencil, as an external memory storage system. Weak executive function shows up as sloppiness, skipping steps, reversing the order of operations, like doing the subtraction before marking the borrow. Poor format, bad handwriting, failing to align digits, or refusing to write down auxiliary marks like carryovers. These non-standard habits, which often pass in low-grade math, become catastrophic in higher grades. As educators and parents, we must demand procedural rigor from the start. Standardization is what allows a student with average brain power to stably solve a complicated problem. If you see recurring errors, stop calling it roughness or carelessness. Look at the underlying ability. Are the neural pathways weak? Is the working memory strained? Is the student skipping procedures? Address the skill, not the attitude. The secret to accuracy is not speed, it's stability. Focus on building these 3 foundational pillars and you will find a brand new experience of learning maths.